Now we will find the shear force and bending moment diagram for a simply supported beam subject to a uniformly distributed load W per unit length. That is, this load is W per unit length. First of all, let us draw the free body diagram. Hinge support is replaced by one direction upward RA. Roller support is replaced by another direction RB, and this total load will be equal to W into L, and that will act at the center. W into L at a distance of L by 2 from RA and L by 2 from RB. Now we will calculate the reactions by using the equilibrium conditions, that is clockwise movement equal to anti-clockwise movement, and we will take the movement at point A. Clockwise will be WL into L by 2, clockwise WL into L by 2, and anti-clockwise about point A will be RB into L, anti-clockwise RB into L. So from here RB will come out to be L and L cancel, WL by 2. Other equation, upward forces equal to downward forces. Upward forces are RA plus RB, that will be equal to downward forces WL. Therefore RA will be equal to WL minus RB, that is WL by 2. So this will come out to be WL by 2. So these are two reactions at point A and B. Next, we'll find the shear force at various points by considering a right hand side of the beam or left side of the beam by taking these sign convention. Now we'll consider right side of the beam. The shear force at point B will be upward RB. So upward force will be taken as negative minus RB, that is minus WL by 2. The shear force at point C, again we will consider the right hand side of the beam. Downward force is positive, upward negative, plus. So at point C, by considering the forces on the right side, the right side there are two forces. RB is upward, whereas only half of the UDL is on the right side. So half UDL will be how much? W into L by 2. Half. We will not consider this force WL. I am considering half UDL only. So half UDL will be equal to WL by 2 minus RB. That will be equal to 0. Now shear force at point A, we will consider the left hand side of the section. Upward force will be positive. So consider left side, only one shear force upward RA plus. So that shear force at point A will be equal to WL by 2. So this diagram is only for calculating your reactions. In order to draw the shear force and bending moment diagram, we have to consider this diagram. Now we will calculate the bending moments by taking this sign convention. Right side, left side, right side your anti-clockwise is positive and left side your clockwise is positive. Now bending moment about point A, we will consider left hand side of the section. Moment of RA at A will be 0. Similarly, consider the bending moment at point B by considering right hand side of the section. Moment of RB at B will be 0. So, always at support, the bending moment at A and B is 0. Now we will find the bending moment about point C by considering this diagram. So this is point C. Bending moment at C will be equal to RB, this reaction RB at this point, RB multiplied by L by 2. This will be in your anti-clockwise direction. So anti-clockwise movement is taken as positive. So this will be equal to RB into L by 2 positive. At point C, the other is half UDL. Half UDL at point C, half UDL movement will be equal to Half you did is W into L by 2. This is the force. W into L by 2. Force multiplied by the distance. It will act at the center. So at the center, the distance will be L by 2 half. That is L by 4 into L by 4. And this force will act downward. So at point C, its movement will be in which direction? In clockwise direction. Therefore, it will be taken as negative. So this will be equal to RB is WL by 2 into L by 2 minus WL square by 4. So this will be equal to, sorry, this is 4, 8. So this will be equal to WL square by 4 minus WL square by 8. That will come out to be WL square by 8 positive. So this is the bending moment at center. Now we will draw the shear force and bending moment diagram. The shear force at point B is minus W by 2 downward. At point C is 0. At point A is plus W by 2. Now from B to C there is a UDL. So this will be a inclined line. And again from A to C it will be UDL. So this will be positive. This will be negative. And the bending moment diagram, at point A bending moment is 0, at point B bending moment is again 0, and at center the bending moment was WL square by 8. So at center it is WL square by 8. If the shear force line is inclined, the bending moment like will be parabolic, like this and like this. So this is positive, the bending moment diagram, as there is the sagging load, therefore the bending moment diagram is positive.